Let's work toward another example in Chapter 6, Bending Plastic Moment Calculation. So we want to calculate, in this example, we want to calculate the plastic moment for I-beam section as provided in below in terms of ton times meter. Let's see how to solve this problem. So the very first thing we need to do for calculation of a elastic moment, we need to calculate the centroid. For calculating the plastic moment, we need to find the same amount of areas. So by that, so if this is the plastic center line, it just says area at the top A1 should be exactly the same as A2. So the very first part is to calculate the two uh, equal areas. So in that terms, we need to have A1, which is at the top here, is equal to A2, which is the upper part of the section. Area of the top part of the section should be equal to the lower part, and to do that, if we just consider this distance x downward, that's a 20, and the dimensions are also provided in centimeters. So that's 20, and which is provided in problem statement, and times 1 for the top flange, and that's 20 times 1 plus x, I don't know where x is, times the thickness of web, which is 1 centimeter, and that's equal to area at the lower section, which is 20 times 2 plus 13 minus x, this small distance here, which I just don't know what it is, times again the thickness of web. So if you do the math, it just gives you 20 plus x at the left side. It's equal to 40 plus 30 minus x. So that's 2x equal to 50. X is equal to 25 centimeters. So this downward is 25. The other definitely is 5. So this is 25. This is 5. This is neutral line for plastic. Mhm. Or plastic neutral line, which just says A1 should be equal to A2. As soon as we have a, the area of two section due to plastic neutral line or plastic center, so we can now go like normal and calculate a centroid for the top part, and again centroid for the lower part, and the distance between the two centroid time half of the area, z times sigma y is equal to the amount of moment plastic. So let's solve it. So the centroid for the upper part, mhm, that's the centroid for A1 up to here. And if we want to calculate the centroid, it's just summation of area times xi or yi over summation of area. Mm. And if you do so, that gives us a 20 times 1 top flange area times 25.5, which is the distance of centroid for top flange to plastic neutral plastic center. That's a 25.5 because this is 1 and this is 0.5 centimeters. Plus the other part is the location, the part of A1 which is located on web at web. So that's 25 times 5 times 20, 12.5, which is the center for the web part. So that's 25 times 1 times 12.5 over the half of the area, which is 20 plus a 20 5. Mm? That's the area chunk of the web in upper section and the top flange. And if you do the math, it just gives you 18.28 centimeters. Do the same process for the lower section, and that gives us what is the centroid for lower part. So that's again AIXI over sigma AI. So, and if you just want to, uh, that could be also Y1. If you just consider this one, because I consider that one like X, so I just call it that way. It's just a how you name it. Mhm. The concept is the same. So that gives us the 20 times 2, 20 times 2, mhm, times 6. This is 5 plus a 1 centimeter addition to that. That's a 6 centimeters distance, plus a 5 times 1, 5 times 1. mhm, This is 1 and this is 5. So this area is 5 centimeters squared times 2.5, which is the center. Again, over half of the area. Again, this time is that's 2 times 20 plus 5, that's 45. And if you do the math, it just gives you 5.61 centimeters. So if you add up the two centroid, do you remember from the plastic moment center formula? That's a capital Z is the distance between the two centroid at the upper and lower section, and that gives you 23.89 centimeters. And likewise, plastic moment is equal to half of the area times Z times sigma Y. And that Z is just the distance between the two centroid times sigma Y, which is provided in the problem statement to be 2500 a kilogram over centimeter squared, and 45 is half of the area, and we just calculated Z to be 23.89. And if you do the math, gives you this numeric value in kilogram times centimeters. And we want, if you convert that to ton times meter, the plastic moment is just 26.87 ton times meter. We'll solve one more example in plastic moment in next video, and that's all for the plastic moment calculations. Thank you.